Hello everyone. Today we'll be discussing a question wherein you are given a binary tree and we have to convert it into a doubly linked list in place. So the left and the right pointers in nodes, right, are to be used as the previous and next pointers respectively in the converted doubly linked list. And also the order of nodes in doubly linked list must be the same as in order traversal of the given binary tree, right? So the first node of the in-order traversal, leftmost node, which is 25 here in this example, must be the head node of the doubly linked list, right? So the in-order traversal of this given tree here is 25, 12, 30, 10, 36, and 15, right? So your doubly linked list that you return, the head of that doubly linked list should be 25. So we'll uh, try and visualize the concept and we'll see what our strategy is behind solving this problem. So you have been given this binary tree, and as discussed, the in order traversal for this tree will be 25, 12, 30, then 10, and then 36, and then 15. So our expected doubly linked list will be 25, 12, 30, 10, 36, and 15, right? So this is the expected doubly linked list, and this will be our head, right? So the basic idea of solving this problem is we do an in-order traversal of this tree, and while doing the in-order traversal, what we'll do is like we'll make the left pointer of a particular node to point to the previous nodes, and at the same time we'll have to store the previous nodes, right? To point it to point the left pointer of the node to that previous pointer, we'll store the previously visited nodes in some sort of variable or a pointer, right? So we'll try and visualize the concept. So let's say uh, we do a in order traversal. Let's say how do we implement an in order traversal, right? So let's say what we do is we do a in order traversal of the root node, right? So we visit the left node, then we do some sort of computation with the current root node. So let's say we just say we have something like visit root, right? And then we move on to the right subtree, right? So we have something like this. So the idea in converting this binary tree to the corresponding doubly linked list, we do a in order traversal, and at the same time we'll try and store the previously visited nodes, right? So what we do is, let's say, so let's say initially our previous pointer, so I'll use a different color. Let's say this. Initially our previous pointer is null, right? So what we do is, while doing the in order traversal, our visit will be something like, we say root dot left is equals to previous. And to store the previously visited node, which will be the root in this case, will store previous equals to root, right? We'll try and visualize here. So let's say this is a call stack. Uh, Let me use, right? Okay. So for simplicity, I would be just calling my function as I, and I'll change. Let's say we start visiting at this node. So it will be I of 10. Then we move to I of 12. Then we move to I of 25. So, also here, if root will be null, right? We just return null, return root or null, because it's same, right? So once we reach here, so we started from here, we we move to this recursion. From this line, we go to this 12, then we go to this, right? And then we move to this, which is a null pointer. So it is something like I of null, right? So I of null returns null, this returns null, right? So here we get a null, here we get a null from here, right? So we get a null from left. So what we do is, we say root dot left is previous. So previous currently is null, right? So we say 25's left is null. And then we say previous equals to root. So this becomes a previous. So this becomes a previous. We move to the right. We move to the right of the current root. So 25's right is again null, and then we'll pop this left, because anyways this is over, right? So we pop the left, we pop this left, and then again we get, we move here, which is again null, right? Which again returns null, correct? So what is expected? This will become null. This will be popped out of the stack, right? So we have null returning from here, right? And then our our I of 25 is also will also return, right? So in that case, what happens is the current root now is 12 in this, right? So we'll set root when we come to this call stack, so root is 12. So 12 dot left is previous. Previous currently is 25. So we'll have something like 12 previous is set to this, right? And now previous will become, now this 12 will be our previous, right? Now we'll move to the 12, right of the 12. So now right is 30. So we add 30 to the call stack. Then what we do is like we move to the left. We move to the left of this, which will return null, right? So I of null, this returns null, right? And then this returns null. And what we do is like when root dot left, we moved to uh, I of 30 as of now. So now our root is 30, right? And then we move to the left of 30, which was null. It returned null. Then we have to visit the root, right? So the root here is 30, and we set previous of 30 to the previous node. So left of the current root to previous node. So the previous visited node is still 12. So we set 30 is left to 12, right? And then we move to the, then we move our previous pointer to 30, right? Then we move to the right of root 30 here, which is again null, and it will again return null, right? So it will be I of null, which returns null basically, correct? So we can remove this. Now we have visited the node 30, and then node 12, because we have visited the right side of the node as well, right? Now in the call stack we have node 10. So we'll have to visit we have completely visited the left part of the tree, which is this, which is this. We have completely visited this part of the tree. Now we need to visit the root itself, 10. So we'll make tens. So tens left to the previous, right? Here. And previous to root. So tens left is tens left will be the previous, which is 30. And we'll make this. So the current previous, now we'll say the previously visited node will be 10, right? Then we move to the right in this recursion, right? So we go to 15, I of 15. Root is now null. We move to the left of this node. So which is I of 36. Then we move to null. I of null. Left 36, left of 36 is null. We move to null, which returns null, right? Then what we have to do is, so this returns null. So current node is 36. So what we do is like the we'll set the left of the current node to the previous node, and then we'll set the current node to the previous, right? So 36 previous becomes 10, right? And we set, and what we do is like we set the current previous. So 10 is listed. So we'll set our current. So 36 becomes the previous, right? Now we'll move to the right of 36, which is again null. So we have something like null, which again returns null. So so that recursion for node 36 will be complete, as both the left and the right side subtree will be complete, right? Then we move to the node 15. So left subtree of the node 15 is complete, which is this part, right? So we visit the node 15. What we do, we set the left of the previous node to the previous node, which is left of the current node to the previous node, which is 36 here, and then make the current node as previous, right? So we make current node as previous, and then we visit the right, which is null. So in this case, we visit the right, which is null, and it returns null, right? So this returns null, and then the left and the right subtree of node 15 are done. So we can return, right? Now the left and the right subtree of 10 is also done. This is done. And then we return from this recursion. So we got something like this, right? But this is not the expected answer, right? So we need to do something else. So we have the root 10, and then it has it is here, right? And in the tree it is here. So what do you think the last node in the doubly linked list will be? It will be the rightmost node in the binary tree, right? So this node, which is this this 15, right, will be the rightmost pointer in the doubly linked list. The rightmost pointer in the binary tree, which is the last element in the in-order traversal, will also be the last element in the doubly linked list. So what we do is, starting from the root, we start moving to the rightmost element. So in this case, this is the rightmost element. This is a simple example. So we move to this, and then what we do is we'll start connecting the left of the node, which is 15, to it. So we'll make this left, we'll reach to 15, then we'll proceed to the left of this current 15, then we'll set the left's right to 15. So it will become something like this. So once we start coding, it will become simpler to understand. I'll show you. So we'll keep on doing this till the till something like root dot left is not equal to none, right? So I hope you understand the concept. We'll try and implement this, let's say, in Python. So this is also done. So we can pop it out. And at the end, what we do is like we return this the head, which will be this, right? Basically, at the end, head will be this 25. So we'll handle that in our code somehow. This, right? So we'll see the code. So basically we'll try and implement a tree node. So it will be object, and then we can have something serve.val and serve.left as initially set to none, serve.right initially set to none. And we can have a binary tree class, and we have object, and we define the constructor, which is fine, and then we'll say serve.root equals to none. So basically we have a tree, then we'll do uh, say print and then self root, right? If root is not equal to none, right, we do self dot print in order root dot left, and we print the root dot val, and then self dot print in order root dot right. Right? So this should suffice our requirement for binary tree. Let's test this. So we have a binary tree, and then I have hard coded this tree in this example. So the in order traversal should be 25, 12, 30, 10, 36, and 15. Let's see. So yeah, 25, 12, 30, 10, 36, and 15. So we'll try and implement these methods, find previous pointers. Okay. So we'll have something like find previous pointer, self, and then root, right? So basically, if the root is none, we return the root itself or none, anything that is fine. Then we do a in order traversal. Like I said, doing an in order traversal is something similar to like visiting the left subtree fully, then the node, and then the right subtree, right? Self dot find previous pointers, then root dot left. Then what we have to do, okay, so this is how we store our previous pointer. So let's say currently it is none. So like I said, so initially it was null, right? So this thing initially it was null. So initially we have set it to none in Python, which is equivalent to being a null or an empty value, right? So we have this, and then what we have to do is we have to set the current root, which is root here, right? So just like this, we are printing root dot value. So in order traversal, we'll be doing something like this: root dot left is equals to self dot previous, right? And then what we do is like we store now self dot previous will be current root. Why? Like I was discussing. So once once we started going deep into the recursion, right? So we started from 10, right? We started from, let's say, we started from 10, then we moved to 12, then we moved to 25. Okay. And at the same time, while doing an in order traversal, what we were doing is like we were setting the root dot left to the previous, right? So once we reach this point, right, 25, and the left of it is null, which returned, and then what we started doing is like we did set 25's left to null, right? And then what we did is we set the previous itself to 25, right? So this is what we are trying to achieve in the code itself, right? Then we do move to the right subtree, find previous pointer, root dot right, right? And then we, like I said, currently it has just created the left link in the linked list. So in the expected linked list, doubly linked list that we have to return, it has just created a left link to every respective node, to every previously visited node by the current node, right? So what we need to do is we somehow need to, like we discussed in the previous scenario, though, so the rightmost, the end of the doubly linked list will be the rightmost node of the tree, and then in order traversal. So what we can do is like we can have something like find uh, next pointer, let's say. So we'll pass the same node. So when we say pass the same node, we'll pass 10 only, right? So what we do is like we'll have to find the rightmost of the 10. 10 is the root of the tree, right? So we'll have something like define next pointer self dot root, right? So we move to the rightmost part of the tree, right? So while root dot right is not equal to, we keep on moving. Root is equal to root dot right. We keep on moving towards the rightmost part of the tree, right? Then once we have reached, what we do is like we start creating a right link from the uh, current left element of the current node. So I'll try and explain. So we have reached to this point. So we have reached to this point as of now here. Now we have to start connecting this 36 to 15, and uh, then 15 to, so right, we need to start connecting 36 to uh, 15, and then 30 to 10, and then 10 to 36, and the left and from 10 to 36, that is tens, we have to make tens right 36, and similarly 36 right as 15, and similarly 12 right as 30, right? So what we do is like we will move to the rightmost of the tree. Once we move to the rightmost of the tree, now what we'll do is if root is not equal to none and root dot left, right? Because we have already stored the left pointers, so we can traverse in the left direction, right? So what we'll do is like we'll store the left. So let's say root dot left. So here we know the 15th left is 36 in our in our traversal of I mean in our traversal we created the link to the previously visited node. So 15th left is 36, we know, so we got 36 here. We get 36 here, right? So what we have to do is we have to set the left's right to the root. Now we are linking, right? So this link which I was discussing, right? So let's say I'll try and traverse that code again. What I'll do is like I will clear these links. So this is what we had achieved after doing an in order traversal. Now we are at this point, and then we already knew the left of 15 as 36. So left of that 15 is 36. Now 15's right we are setting to the current root, so which is 15 here. So what we are doing is we're saying set 36 right to 15, right? Then we'll move to the left, and we'll keep on moving till the roots dot left becomes null. So we'll move to here, then we'll make tens right to 36, then we'll move here, then similarly we do something like this, right? So we come here, and then now we have set the link, and then what we have to do is root is equals to root dot left, right? And then finally we can return root, which will be the head. And then we can have something like, to prove that we are correct, we can have something like print dll, right? So it will be something like root. So what we can do is for now we'll just say root. while current is not equals to none, int current dot val, then we move the current to the current's right. So we'll see how good is our implementation. Let's check. So we were, as of now, we were doing just an in order traversal, which we got like this, right? Oh, I'll just comment it out so that you can be sure that so we do a find previous pointer, which we got a previous pointer on DLL head. The previous pointer in this case will be 25, right? DLL head, right? So now we need to print that head. So we'll be moving from 25 to 12, 12 to 30, 30 to 10, 36, and 15. It should be in this order, right? So let's see. Okay, binary tree object has no attribute print DLL line 84. Okay. Okay, this is small and this is capital. So I'll change this and it should work. Okay, so we got this. So I hope you understood the basic concept behind converting a binary tree into a doubly linked list. But practically the most, more important question might be to convert a given doubly linked list into a binary tree, such that what happens is like in real life scenarios, let's say you are asked to find uh, a value in a doubly linked list, right? So finding a value in a doubly linked list will be even if you're going from left to the right, it would be usually big often, right? In general, right? It would be big often because you will be traversing each element one by one, right? So obviously it is better than a single linked list, but yes, still it will be big often. So what we can do is like we can convert a doubly linked list into a binary, let's say binary search tree. So searching a node will become log of n, where n will be the number of nodes in a doubly linked list. We can convert it to a balanced binary search tree and it would be more efficient. Thank you so much, guys. So I hope you liked it. If you have any queries, please leave them